Hi children, how are you? In this video, we are going to discuss the types of chemical reactions. In the last video, we had discussed the definition, how to write for a chemical equation and how to express the word equation, and also we had expressed a chemical equation is the one in which we represent the reacting substances and the formed products in the form of their chemical symbols. And the chemical reaction is the one in which some substances react with one another to form new different substances. That is, a chemical reaction is the one in which reactants react chemically with each other to form the products that are new substances. There are many types of chemical reactions. In our grade 10 standard, we had given with few. We are studying the first kind of chemical reaction, that is called as the combination reactions. Combination reactions. The word combination itself, it is explaining that some of the substances are going to combine with each other to form a new substance. One example let us take here. We know about whitewash. What is meant by whitewash? The wash that we will apply for the wall that was recently constructed. Let us get some formulas first, then we will continue with this one. The first formula that we are studying here is CaO. Chemically it is called calcium oxide or quicklime. Calcium hydroxide, CaOH twice. This is also called as slaked lime. Also called as slaked lime. CaCO3, calcium carbonate or limestone. Calcium carbonate or limestone. So these are the three important names, general names, and their chemical names. These are the general names. These are their chemical names. So let us start by using one of the starting compound, calcium oxide, and how to make our reaction completed. So let us see here. When we are going to dissolve this quicklime, usually quicklime will be in the solid state. When we are going to dissolve it in water, we can expect many products. One of the major products that we are getting is CaOH twice. We have one calcium here and one oxygen in the quicklime, and in the water there are two hydrogens and one oxygen. These both are called reactants. These both are called reactants. And when the two or more reactants are combined with each other, they have formed only one product. They have formed only one product, that is called slaked lime. It is generally dissolved in water, so we mention it as aqueous state. So we are going to come to the conclusion point. What is meant by a combination reaction? Combination reactions are those in which to form one substance. We give a definition here. The reactions in which two or more substances, that is reactants, reacts with each other to form a single substance, that is product, different from reactant, is known as combination reaction. Is known as combination reaction. Very important definition for the first one. So this is the example number 1 that we had seen. Now, is there any importance for this slate line in our day-to-day life? Yes, we had already explained. Whenever we had constructed a wall, first of all they will apply the whitewash. This slate line is also called as the whitewash. What does it will happen when we apply onto the wall? Let us see the application. How is it going to be happen? Whenever we study here, the slate line that we had chosen, when we apply onto the wall, it will be left for 2 to 3 days. When it is left for 2 to 3 days, the atmospheric carbon dioxide will start reacting with our slate line. Atmosphere carbon dioxide will be start reacting with our slate line. When we apply initially, that will be very pale or dull in color. But when it is left for 2 to 3 days, we get a very bright white color. Why? Because this slate line, that is aqueous in condition, when applied onto the wall, that is going to react with atmospheric carbon dioxide for the formation of calcium carbonate. What is the color of the chalk piece we had? We can find the piece of chalk is white in color. What is the formula of chalk piece? Calcium carbonate. The wall is also white in color because the slate line that we had applied is going to react with atmospheric carbon dioxide and that is going to form the white colored calcium carbonate. So we call this one as the whitewash. It is called the whitewash. Slate line is called as the whitewash. This is the application for the first example, that is reaction of calcium oxide with water. We got slate line. Once we apply on the wall, it is forming the white colored calcium carbonate, giving white colored wall for us. Now we are going to see this one. How do we do in the chemistry lab? We need to take a small beaker. Around 250 ml. I am using around 250 ml beaker. beaker. In this beaker, I had used placing some amount of water. Into this water, I am adding some amount of calcium oxide. The formula of water will be H2O. Formula of water will be H2O. When we are doing this reaction, we can clearly observe when both these are combined, they will give calcium hydroxide. That's called Slater-like. But you must touch the walls of the container and observe what type of heat is it giving or is it absorbing. When we touch the walls of the beaker, we will observe some heat is evolved out of the container. Means heat is going to be given from the reaction to the surroundings. These type of reactions, we are going to call them as the exothermic reactions. What are we calling them as the exothermic reactions? Exothermic reactions. The reactions in which heat is released during a chemical reaction. It is released during a chemical reaction. Those reactions requires the exothermic reactions. Can you imagine one more example? That is, when our mother had taken a pan and she had placed some water, then she placed some noodles into the water by adding the given ingredients, masala along with the noodles. If we place it on the stove, do we get the tasty noodles without turning on the gas? We may not get, because without heating, the raw noodles cannot be converted into the noodles that we take in. So once we observe what is the reaction happening there. When the gas is coming out, first you had started igniting it in the presence of oxygen. What is the main gas that we find in the cylinder? That's we call methane. That will burn in the presence of oxygen. In the presence of oxygen. So we are identifying the equation there. Methane gas, when reacted with or undergoing combustion with oxygen gas, is undergoing combustion with oxygen gas, it is going to form carbon dioxide. See children, I have given carbon dioxide that we don't observe because the emitted carbon will be very less than amount, and it is going to form water. This will be in the gaseous state. Along with that, heat energy is released. That heat energy we use for cooking. So, shall we call this one is also an exothermic reaction? Because what is an exothermic reaction? The reactions in which heat is released during a chemical reaction. In this reaction also heat energy is released. That is, we call cooking is an exothermic reaction. Now, can you put balance the reactants and products? Let's start doing. In this case, we are going to do a balanced equation directly. We had 4 hydrogens here, but we didn't balance the oxygens. Since we are going to balance 2 2s are 4 hydrogens, we want 2 oxygens and 2 oxygens to combine with carbon. So we had given 2 moles of oxygen. The example number 2 we are discussed now. Let us take one one more example. Our respiration, when we inhale and exhale, inhale, exhale, do you find any little warm gases getting out of your nose? Yes, you will feel that little warm gases coming out of your nose. What about the food what we take inside? It is a carbohydrate. You may take rice or you may take a potato or you may take the grain, wheat, chapatis, whatever they may be. They are hydrocarbons, there are sugars. One of the compound that we are taking is with the glucose molecule that is present in it. Generally we want to write in solid state, but we had already consumed the food into the body. The food that we have eaten is mixed along with water. So we must not use solid, we will use the symbol aqueous. When we are respiring, the oxygen is going to react with this glucose. Oxygen is going to react with this glucose to form various products, that is carbon dioxide, water vapor and energy is released. The energy we do the work, but here carbon dioxide is little warm in nature, that is what we feel. Is the equation balanced in condition? How many carbons we find on the reactant side? We find 6 carbons on the reactant side. So let's place here 6 to balance the carbons. How many hydrogens we got here? 12. But here we got only 2. So shall we make this one as 6? So now there are 6 hydrogens. 6 2s are 12. On the product side, how many oxygens are there? 6 oxygens here we have, and 6 2s are 12. Means totally we had 18 oxygens. These 18 oxygens, once you see here, there are already 6 oxygens on the reactant side. So you want remaining 12. The remaining 12 we can write as the 6O2. We can write as the 6O2. So respiration is also an exothermic process. Respiration is also an exothermic process. Respiration is an exothermic process. Burning of fuel is also an exothermic process. This is also an exothermic process. And we had the first equation, that is reacting calcium oxide with water is also an exothermic process. So we can conclude now exothermic reactions are the reactions in which heat energy is released outside. Then what are the reactions that we call heat will be taken up? The reactions in which heat will be taken up were called endothermic reactions. What are they called as the endothermic reactions? Endothermic reactions. We will discuss them in our next class about endothermic reactions. So let us continue with the endothermic reactions. Exothermic reactions means the reactions in which heat energy is released during a chemical reaction. But endothermic reactions means the reactions in which heat is absorbed during a chemical reaction. It is absorbed during a chemical reaction. Means during a chemical change, heat will be absorbed. examples. All decomposition reactions are the examples for endothermic reactions. So we didn't get this word. What is meant by a decomposition reaction? We had discussed only about combination reaction. So let us give one clarification. During combination, reactants used to combine to give one product. The reverse you think? One reactant will give two or more products. One reactant will give two or more products during a chemical reaction. Those are called as decomposition reactions. So let us give the definition first. Decomposition reactions. Decomposition reactions are those in which one substance, that is reactant, breaks down or decomposes to give two or more new substances. Two or more substances, that is products. So what is the decomposition reaction? Decomposition reactions are those in which one substance, one reactant breaks down or decomposes to give two or more new substances, that is products. So this is reverse for the combination reaction.